Hi, this is Mr. Max. So I'm doing my second part on my work on differentiation. So again, um, it's going to be a video that is quite interactive. Let's just go and start directly with the questions, okay? There is a point P, 3,5, and this point lie on this particular curve. They want you to find the x-coordinate of the point where the normal to the curve at P intersects the x-axis. Now, let's just write this equation because the moment we have got normal and those things, there is differentiation involved. So, let me just write this one in this form so that it is much easier for you to work it out. So let's derive, and the derivative of this, of course, the derivative is nothing but dy dx would be negative here, then you have x minus 1, now this is going to be minus 2, okay, plus, so we're going to have a plus here, negative 1 times negative 9, then you have x minus 5, and that is going to be minus 2. So once you are now at this particular level, you're going to say this is going to be, just rewrite it nicely as perhaps minus 1 all over x minus 1 squared. So perhaps we can just bring the minus here in front, and then that's plus 1 all over x minus 5 all squared. Okay. Now, what is our point? Our point P is the point 3,5. So we're going to take the x value of that, and we are going to substitute into the derivative function when x equals to 3. That is going to be negative 1, and that is going to be 3 minus 1 all squared plus 1. That's 3 minus 5 all squared. So once you do that, this is going to give you a gradient of 2. So what this is the gradient of the tangent, because that is what this is. This is the gradient of the tangent. But we're not looking for the gradient of the tangent, because the question asks us to find the normal. It says to find the x-coordinate of the point where the normal to the curve at P intersects with the x-axis. So in order for us to find that point, we need to know what is the equation of the normal. Okay, so looking at our equation of the normal, what we will know one thing is, if that is the gradient of the tangent, then the gradient of the normal will be negative a half. Okay, so the equation of the normal can be calculated at that point 3,5 that we were given, would be y minus 5 equals to the gradient, which is negative a half, x minus 3. So when we clean this up, this is y minus 5 is equal to negative a half of x. Negative for the negative is positive, and a half times that is nothing but 3 halves. So we bring that 5 back. So the equation is now y equals to negative 1/2 of x. And if you bring the 5 and you add it, you're obviously going to get 6.5. Okay, let's just go back to the problem. It says the x-coordinate of the point where the normal to the curve at P intersects the x-axis. When that happened, y will be 0. Okay. So for x-intercept, it implies that y will be 0. So how do we find that? So we know that is the equation of the normal. So we have to find what would be the x intercept or the x value. So we're going to say let 0 y be 0, then you have negative a half of x plus 6 half. Well, you can play around with this. This is going to give you nothing but negative 6 halves equals to negative half of x. Okay. X will be nothing but 13. So 6 times 2 is 12, 12 times that is, so it's 13 halves equals to, I can have a negative, of course, negative 1 over 2x. Okay. If the denominators are the same, we can drop them. This implies that x is equal to 13. Clear? Right. They want us, or they wanted us rather, to find the x coordinate. So the x coordinate is 13. We don't want us to find the coordinate pair. For the x coordinate of each stationary point. So let us just clear something again. We know dy dx is equal to, from our previous work, 1 over x minus 1 all squared plus 9 over x minus 5 all squared. So when we are bringing in words like stationary point, this has to equal to 0. Because the x-coordinate of each stationary point in a curve, we have to find that. Then we'll determine the nature of that. So we're going to do that by looking at the second derivative. So this leaves us with, equations of the form cross multiply kind of idea. We're going to have minus 1, then you have x minus 5 all squared plus 9 x minus 1 all squared, and all this is going to equal to 0. Okay. Then we have a little bit of work that we need to do. So make sure your algebra is sound. So that's x squared minus 10x plus 25 plus 9. So it's x squared minus 2x plus 1 is equal to 0. Then of course this is going to give you minus x squared plus 10x minus 25 plus 9x squared minus 18x plus 9 equals to 0. This whole thing will give you 8x squared minus 8x minus 16 is equal to 0. There's something else you can do. You can divide throughout by 8. And if you do that, this is going to give you x squared minus x minus 2 equals to 0. This quadratic is factorizing. It's going to be x plus 1 x minus 2 is equal to 0. Then x is equal to negative 1 or x is equal to 2. Good. So we have now found the x coordinate of each of the stationary points. Now they want us to determine the nature of each of those points. So when x, let's start with the first one. When x equals to negative 1, Then the second derivative, which is d2y dx squared. So remember, the second derivative is going to be nothing but, let me bring down the first derivative so we can just have it clearly. So that's the first derivative over there. Okay, I'm going to write that one down. Just remove all of this before. So the first derivative, dy dx, was -1, and it was x minus 1 whole squared plus 9, and it was x minus 5 whole squared. The second derivative, d2y dx squared, is going to be -1 all over. It's going to be x minus 1 cubed. Then the reason you're going to have 18 here, you're going to have x minus 5 cubed. When x is equal to, so this is what we're going to use. When x is equal to -1, that is going to be, everywhere you have an x, -1 minus 1 cubed minus 18, -1 minus 5 cubed. If you do that, you get -1 over 6. So if that is the case, if this answer is less than 0, it means this is a maximum point. Clear? Same, when x is equal to, we had another value. When x was equal to 2, that's -1, so you have 2 minus 1 cubed minus 18. You add 2 minus 5 cubed. You punch that in, you get 2 and 2/3. What do you realize? Well, this value here, this value is greater than 0. Therefore, it's going to be a minimum stationary point at x equals to 2. Okay. Well, if I was to sketch the graph, you would exactly see what I mean by that. Let's see. Let's go and grab our function. Let's just uncheck everything so you can just have an idea. It's going to look quite an eventful function. So let's see if we can input that function here. Our function is y equals to, we have got 1 in brackets, you have x minus 1 raised to the power of -1. Then it's going to be discontinuous function. That means it's going to be a break somewhere in there because you have some denominator where the x is. -9, and then you have got in bracket x minus 5 raised to the power of just -1. Okay, this is our function. This is our curve. Right, so it's quite an eventful curve. It has got a break in somewhere here and so on. When x was equal to -1 here, you can see that that is the turning point. So that is a -1, that is a maximum point. Yeah? When x was equal to 2, you can see that is a minimum point. Can you see that? So that is what that gives you there. So those are the two x values that we had to consider. That's how weird that type of function would be. Interesting. Okay. Next question. Question 8. Nice diagram. The diagram shows an open container constructed. This is supposed to be out. Okay, so this is supposed to be out of 200 square centimeters of cardboard. The vertical end pieces are isosceles triangles with 5x, and 8x centimeters respectively. Then you are supposed to, the two sides are rectangles, length y and width 5x, as you can see. We're supposed to show that. So we're going to go into our diagram. So here's something that I need to, first of all, maybe bring in. So if you have this isosceles triangle, and if you were to drop a perpendicular, so this is what I'm referring to. So what that does, it will then bisect this as 4x, and that is 90 degrees over there. Let's take away this horrible diagram. So I have essentially, I have a right angle triangle, like so. This is right angle, that is 4x, this is 5x. We can find this height using Pythagoras. The height will be 5x squared minus 4x squared. That height will be 5x squared minus 4x squared, everything square root. Well, it's going to give you 3x. So now we know what the height is. Okay. That was important to do because we are supposed to show that the area is equal to that. Okay. Again, that could have been something that we have left out there. Show that A equals to that. Right. How do you then do that? Show that A equals to that. That's the area. So we're going to find the area of these two triangles. The area of the two triangles, that's half, times base, which could be 4x, times height, which is 3x. Okay, 3x times 4x, that is 12x squared. So that's going to give you 6x squared. Then you have the area of the two, because it's open, right? It says that the container is open. So basically this rectangle on this side and the rectangle on the other side. So area of the two rectangle with y times 5x. So I'm going to say area of two rectangles, that is going to be 5x y, and there are two, that gives you 10xy. Okay, that's the area of those two. So what is it that they are telling us? They are telling us that this is equal to 200 square centimeters, that whole material. So we're going to take this two. We're going to say, I just want to make sure of something with my triangle. I'm not supposed to use the 4x here because it's two of these triangles. I'm looking for the whole triangle here, so my base can't be 4. My base has to be 8. Just make sure we make sure of that, okay? The base has to be 8. So 8x times 3, well, that gives you 24x if you catch my drift. And another thing, I did not, so I must multiply them by 2. So basically those 2.5 cancel. I've got 24x squared. Now I think it makes more sense. Now what we have a scenario where the total surface area, the 24x squared plus 10xy is equal to 200. So we are going to write this in terms of y, okay? So once we do that, of course, because they say we are supposed to show this, so this is not the area, so to speak. This is y. Okay. Show that y is equal to that. So that means we're going to make y the subject of the formula here. So that is 10xy equals to 200 minus 24x squared. And then we're going to have everything there divided by 10x. So y will be 200 minus 24x squared. We're going to divide that by 10x, which is what we were supposed to prove anyway. Does that make sense? Good. Now show the volume. So little problem here as well. It was a typo. This is supposed to be a cube. Okay. We're supposed to show. So the volume is the area of the cross section, which is a triangle, half base times height. Then we're going to multiply that with the height or the length. Okay. So from our diagram, the cross section is a triangle, and we say that the volume is equal to a half. The base is 8x, as I already said. The height is the one that we use Pythagoras to calculate, and the height here is just y, or the length. Okay, the height that we are referring to is the distance between the two cross sections, okay, which is a triangle here, triangle there. That's the y we're talking about. Now we can just go ahead and clean this up a bit. Okay, so this gives us 24x squared. Half of that is going to be 12x squared. The problem is our y from before, our y is now represented by that whole business that we had over here. So this is going to be taking up the place of y now. 200 minus 24x squared upon 10x. Okay? So that is going to be 200 minus 24x squared all over 10x. Okay. So let's clean up. Excuse me. Let's clean up and see if we do get what was required. There are many ways you can do this. Of course, you can go ahead and say this x cancel, and 10 goes into 12. That is 1.2x is going to be there. Then I have 200 minus 24x squared. And now we can actually multiply out. And if we multiply out, v equals to 1.2 times 200, that's 240x, because 1.2 times 100 is 120 times 2 is 240, minus 1.2x times 24x squared. That's going to give you let's take it, 1.2 times 24. Of course, that gives you 28.8. 28.8. So that's 28.8x cubed. That's why I said you are supposed to correct that. Okay, so this is just straightforward grade 11 work, if you have to say ordinary mathematics. Right, they will now say something varies. Given x can vary, the moment they come up with those things, this is where you have to think of differentiation. Okay, because it wants you to find the value or the stationary or find the value of x for which v has a stationary value. So it's our v was nothing but 240x minus 28.8x cube. So we are going to do dv dx. Okay, it's rather terrible handwriting. Dv dx is going to be nothing but, if you look at it, this is going to be, 1 times that is going to be 240. Okay, so it's 240. And then you have minus 3 times that is going to be 86.4. And reducing 1 there is going to be x squared. Now, the moment they talk about stationary point, this has to equal to 0. And if you were to calculate this out, you have minus 86.4 x squared is equal to 240. You should get that x is equal to nothing but 5 over 3. And x should be greater than 0 because a negative answer will give you a negative volume. The reason I say that is because you are dealing here with squares. You have to take the square root in order for you to get. So you say 240 divided by negative, so this 240 becomes negative as well because it goes, so to speak, over the equal sign. So once you have this negative 240 divided by this negative 86.4, you get an answer, and then you have to take the square of the answer. You can't consider the negative answer because volume will now be negative. Part D, determine whether it is a maximum or a minimum, so you have to find the second derivative. So what do we know? We know dv dx, first derivative function, was 240 minus 86.4 x squared. So when you are told determine whether you are describing a nature, you must now take the second derivative, d2v by dx squared. Well, the derivative of 240 is 0. 2 times that is going to give you negative. Now you can go ahead and punch that in the calculator. You say, what is 86.4 times 2? Okay, that gives you 172.8. 172.8 x was reduced 1. Right. So what do we know? We know from our previous work that x was 5 over 3. And we want to determine the nature to see if it's a maximum value or a minimum value. So when x equals to 5 over 3, then you have minus 172.8 times 5 over 3. Well, you don't have to be a genius to see that you're going to get a negative number anyway. So it's negative 288, and that is less than 0. And if the second derivative is less than 0, then it's a maximum stationary value of v. Okay. Next question, something similar diagram. Question number 9. Very interesting question again. It's quite a lot that you have to do here. You might find yourself bringing in some interesting formula or things that you have to remember. Okay, just excuse the noise. We are moving. The figure shows an open tank in the shape of a triangular prism, as you can see. Vertices, the vertical ends ABE and DCF are identical isosceles triangles. Angle ABE equals angle BAE, which is 30 degrees respectively. Length of AD is 40 centimeters. As you can see, the tank is fixed in position with the open top ABCD horizontal. Water is poured into the tank at a constant rate of 200 cubic centimeters per second, that is dV dt. This one here is dv dt. That's what it is, right? Then the depth of water at depth of water t seconds after filling starts is 8 centimeters, you can see in the second figure. All right, they are saying we're supposed to show that when the depth of the water in the tank is 8 centimeter, the volume V centimeter cube of the water in the tank is given by that formula. All right, so that formula has to be given in terms of the root of 3. So let me just bring in my diagram. Okay, let's see. Just grab the diagram here. So let me snap it. We take this diagram over here and we just bring it down here. Okay. So what do we know? Well, if you were to continue, you would be having a scenario, and this is very important, of the height. This, if I was to continue with this line here, make that line perhaps red. Okay, just ignore that H for now. You will be sitting with a scenario where this is a right angle triangle. And if that is the case, then whatever this distance is will be cut in half. Okay. Then this angle over here will be 60 because that's 90 degrees over there. Okay. And these two are obviously the same. All right. So let me suppose I call this particular part M. So basically I am trying to create a triangle. Let me rather use I have a right angle triangle. Okay. Where this is 30 here, that is 90 there, this is 60, let's say this is M, let's say that's A, let's say that's E. Now if I was to do, let's say I want to find this H. So think perhaps of this triangle that I'm doing, not really triangle AM, because there's something here, if you look nicely, there's something here about similarity. Okay, so I'm not going to say AM there. I'm going to work with this little triangle in blue. So maybe I will say A dash, okay, and M dash. So you can know what I'm referring to, that little one there. So the tangent of 30 degrees, tangent of 30 is going to be, so whatever this distance is, remember, is opposite, which is H, over half of AB. You agree with me? Whatever AB was, we're now finding half of AB. Is that making sense to you? So let's play around with that. If you grab your calculator, you should know from special angles that the tangent, make sure your calculator is in degree mode anyway, so the tangent of 30 degrees, okay, is root 3 upon 3. So this answer over here is equal to that, and that is H, which is half of AB. The objective here is to make AB the subject of the formula, okay, because we need to be able to determine what AB is, and you'll see exactly where I'm going with that. So we can do that by doing quite a number of things, multiplying a half AB times root 3 is equal to 3H. Then AB will be 3h divided by a half divided by root 3. Now, if we just ignore the h and we take the numbers, okay, we ignore the h and ignore, yes, we ignore that. So let's say we have 3 divided by 1 over 2 root 3, you're going to get 2 root 3. So this answer is 2 root 3, obviously h. That is AB. Very important that I did that. So I'm going to use that, my second page. So I'm just going to write down what is AB. AB was 2 root 3 h. Now you will see very obvious why that's important for me to do. The volume of the water in the tank, the volume, you find the volume by taking the area of this triangle, can you see the area of the triangle, times the length. So the volume would be given by, the volume is given by a half base times height times, let me just say length, perpendicular height. So I'm now looking at AB because I want to find the area. The volume V is equal to that. So to find that, we are going to say a half of AB, which is, we have AB as an answer. AB is an answer, so that is going to be a half. And that will be 2 root 3h. Okay. Then you multiply this, this over here, multiplied by h. Just remove this a little bit, because that whole thing was replaced by that. So we're going to multiply that by h. And we know the length is 40 from our diagram. Okay. Just make sure that you guys, the volume is base area times length. The volume is base area times length. So the base area is a half base times height times the length. And we know what is the base now. The base is replaced by 2, that AB that I calculated it, that we calculated from before. Okay, that is our base. Now, once you now have to clean this up, you are going to see a half of 40. Well, or these two cancel. H times h is h squared. 40 times root 3 is 40 root 3 h squared. And this was what they wanted us to prove at the first place. They say the depth of water in the tank, 8 centimeter, this one, the volume, show that the volume V cubic centimeter of the water in the tank is given by that formula. So that's the volume of the water in the tank. Okay. Very interesting if you have to look at that scenario, that right angle triangle, trying to find using tangent. You could also have used the tangent of 60. It's still going to give you the same outcome. Right. There's more. They will talk about the rate of change. Now, from our very first instance, we have noted something down. We had dV dt. volume with respect to time, and it was 200 cubic centimeters per second. You still remember? Let's just go back. The very first thing that I wrote when I was doing that, so dV dt 200 cubic centimeters, the volume with respect to the time. Okay, right. They are saying find the rate at which h is increasing. Okay, so what we are now essentially looking for, we're looking for dH dt. That is what we are looking for. We also know, using from the chain rule, connecting that, we know that dV dt is equal to dV over here, dt over here, and the things we're going to have here will be dH and dH over there. What do we know? We know dV dt is 200. dV dH, do we know what dV dH is? Well, we have to find dV dH. And the way you find dV dH, okay, I'll go back here, is I will have to take this derivative. dV dH will be 2 times that, that's 80 root 3h. This over here is dV dH, which is a calculated value. But then they're also saying, because we're not totally done with this question, I'm going to bring that down. They're giving us a value of h. So dV dH, which is 80 root 3h, I'm going to write it here. dV dH, which was 80 root 3h, and then they are saying h is replaced by 5. So let's just grab our calculator to see what that is. It's going to be a very long number though. So it's 80 times 5 times root 3. Okay, let me just write down what I have. 692 and some odd. 692.8203, 8203, and so on. Now we know what that is. So I'm going to write that on dV dH. dV dH is 692.820323. Just make sure. Multiply that by dH dt. We are looking for dH dt. So to get dH dt alone, you have to divide. So you'll be saying 200 divided by 692.820323. This is going to give you dH dt. That implies that dH dt is equal to 0.289 units, so height, okay, with respect to the time. We're not going to be so much into the units, but that is the answer required. Question 10. The diagram shows a metal plate consisting of a rectangle with sides x and y, as you can see, and a quarter circle. A quarter circle is 1 over 4 is 90 degrees here, so it's 9 over 30 degrees, so it's 90 degrees, 90 over 360, that is where a quarter of a circle comes from. And they are saying the perimeter of the whole plate is 60 centimeters, so we have to express y in terms of x. So let's use the perimeter. So the area or the perimeter, they say express y in terms of x. And to do that, we have to use the perimeter formula. And you should know that the perimeter, which consists of, if you have to look at it, it's x plus y and this distance. Now that distance is an arc length, and the formula to calculate an arc length, So an arc length is a quarter of a circle, or 90 over 360, times the this is circumference, because an arc is part of circumference, and I'm using x because the radius is x. Are we clear? So once you clean this up, this is going to give you nothing but a half, so that is pi x over 2. So this distance over here is pi x over 2. So all of that added together, so I have a 2x plus 2y, okay? So the perimeter, which equal to 60, I have 2x plus 2y plus that arc length should give me 60. They want me to express these things in terms of y, so I must make y the subject of the formula. So I have got to move, so 2y will be left to 60 minus 2x minus pi x over 2. Then what I'm going to do is I'm going to take this whole 60 minus 2x minus pi x over 2, and I am going to divide the whole thing by 2. If you divide, then you're going to get y equals to 30 minus x. Here's the catch, be very careful. A half divided by 2 is 1/4, so that's pi x over 4. So we now know what y is, because it says express y in terms of x. So the second part, show that the area of the plate. So let's just go back and grab that plate. Okay. Let's take a snapshot. So we're going to have the area of the plate. Bring it back here. What do we know? We know that y, and I'm just going to bring the value of y down here. It's going to help me with that. So y equals to 30 minus x minus pi x over 4. Right. So the area is the area of this rectangle. So it's going to be area of rectangle, which is xy. Okay. Now the area of the rectangle is going to be x, but my y is going to be replaced by that whole business that I have over there. 30 minus x. So 30 minus x minus pi x over 4. So let's first find the area of the rectangle. Okay, so it's 30x, that times that, minus x squared minus pi x squared over 4. So that's the area of the rectangle. Next thing, I must find the area of this sector. And the area of a sector, and this sector represent 1/4 of the area of a circle, pi x squared, where x is my radius. And if I was to clean this up, this will give me pi x squared over 4. So we're just going to join them. So the area equals 30 minus x squared minus pi x squared over 4, okay, plus pi x squared over 4. Guess what? This stuff at the end, they cancel, and I'm just going to be left with a, which equals to, just want to see something, because they say show that it's given by that. Just have to go back a little bit and see what is it that we did. 30x minus x squared. So 30x minus x squared. Why do I write it as 30 minus x again here? So let's just clean it up. Can you see this mistake? Mr. Max. Okay. We have a little bit of a hiccup. So let's just go back to our document. We're going to do it in segments. Just bear with me. Okay. Let's restore where we were. All right. So this over here is 30x. So let's bring back my black. That's 30x minus x squared. So that's 30x minus x squared. Of course, these two cancel, leaving me with the required. So it's just going to be 30x minus x squared. That's the area. And that is what we were supposed to show. Okay, as you can see from there. Now, they're probably going to ask us something very. So let's just write down what the area is. The area is 30x minus x squared. When they say find the value of x at which a is stationary, so we have got to do dx. dx is equal to 0. So this implies that dA dx is equal to 0. So when you do that, it's going to be 30 minus 2x is equal to 0. So it's dA by dx. Now you can actually find the value of x very easily by simply saying, okay, 30 minus 2x is equal to 0. That's 30 divided by 2. Okay, so x is equal to 15. Because they say find the value of x equals to 15, at which that is stationary. For this stationary value of a, for this value of a, which was x equals to 15, determine, find this, okay, find the stationary value of a. So they basically want us to find the area now. What is the area? The area formula was 30x minus x squared. So it's going to be 30 times 15 minus 15 squared. They say find the stationary value of a. So we are going to say 30 times 15 minus 225, that is now 225. So the answer is 225. That's it, the area. Then determine whether it's a maximum or a minimum. For you to determine whether it's a maximum or a minimum, you are supposed to do the second derivative. And the first derivative, dA dx, dA dx, dA dx was 30 minus 2x. So if dA dx was 30 minus 2x, then d2a by dx squared is going to be nothing but minus 2. And you can see this is less than 0. And if it's less than 0, it's a maximum value. Okay. The second derivative is less than 0 because it's negative 2. Therefore, we are now looking at a maximum value. Okay. Question 11. I have over here quite a number of questions. that I will do in a third video, but it's the same concept. I also have some questions from past question paper, so you can see the ones that were written, obviously. Okay, so that was from question, once I did, was up to question 11. So we're going to do question 11 in the next video.